Hello students. In our previous video, we learnt about connection of resistors in series. Today in this video, let us learn another way of connecting the resistors in circuit, that is parallel combination of resistors. For this, let us perform an activity. Look at this circuit carefully. In this circuit, 3 bulbs are connected in a parallel combination. When bulbs are connected in parallel combination, a single charge passing through the external circuit would only pass through one of the light bulbs. Thus, if we consider total current in the circuit, then it also will pass through any one bulb at a time, as circuit branches into 3 different paths. If we talk about whole current passing in the circuit, we can say that some current will pass through one bulb at a time and some through other bulb. Thus, the total current will divide amongst 3 branches. If we add more bulbs in the circuit, even then there is no change in their glow. While if we remove a bulb from the circuit, both the remaining bulbs still keep glowing. The main questions of concern from this activity are: as the number of resistors increase, what happens to the overall current within the circuit? Second, as the number of resistors increase, what happens to the overall resistance within the circuit? Third one, if one of the resistors is turned off, what happens to the other resistors in the circuit? Do they remain on, that is lit? Recall students that here filament of bulb is a resistor itself. Let us answer them and understand parallel connection in detail. Let us now understand the arrangement of resistors connected in parallel combination. As we can see that this circuit is an example of resistors connected in parallel combination between points X and Y. Here we can see that a voltmeter and an ammeter are connected in the circuit. From these we can measure the potential difference or voltage and current respectively. Suppose these are V and I respectively. Now disconnect the voltmeter and ammeter and connect these like this to measure the potential difference and current across each resistor. From here we can see that the potential difference across all the resistors remains constant. But the electric current I at point X divides into 3 parts: I1, I2 and I3, each flowing through the resistors R1, R2 and R3 respectively. That is, there will be a current drop through each resistor. We can assure this by measuring current with ammeter. Also observe that total current in the circuit is still same. Now, since this is important, let me explain you again. Look at the screen. You can see that in position 1 of voltmeter, it shows the potential difference or voltage of the whole circuit, and this is equal to the voltage in the branch 1 with resistance R1. This means that in parallel circuit, the voltage remains same. While now look at the readings in the ammeter. They are different at both the locations. In fact, the current in the whole circuit is greater than the current in the individual branches. This means that current is divided. In simple words, we can say that parallel combination is a current divider. Recall that series connection is voltage divider. Yes, it's true. Parallel connection is current divider, while series connection is voltage divider. According to Ohm's law, the amount of current drop depends on the values of resistance, as the value of potential difference is constant. Also, the total current coming out at point Y will be the same as that of current I at point X. So we can write this as I total is equal to I1 plus I2 plus I3. By Ohm's law, V is equal to I total into R total, or I total is equal to V upon R total. V is equal to I1 R1, or I1 is equal to V upon R1, or V is equal to I2 into R2, or I2 is equal to V upon R2, or V is equal to I3 into R3, or I3 is equal to V upon R3. Substituting these in equation, we get V upon R total is equal to V upon R1 plus V upon R2 plus V upon R3. Since the voltage through the circuit is constant, V upon R total is equal to V whole common into 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now by cancelling V on both sides, we get 1 upon R total is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So for parallel circuits, as the number of resistors increases, the overall resistance decreases. And then according to Ohm's law, the current within the circuit increases. This increase in current is consistent with the observation that the bulbs glow brighter in circuit. If an individual bulb in a parallel branch is unscrewed from its socket, then there is still current in the overall circuit and current in the other branches too. So other two bulbs will continue to glow. So students, in this video, we have learned the parallel combination of resistors in a circuit. We also learned that in parallel combination, the resistors are connected parallel between 2 points in a circuit. And the potential difference across all the resistors remains constant, but the current divides at each resistor. Thus, we may conclude that the reciprocal of the equivalent resistance of a group of resistance joined in parallel is equal to the sum of the reciprocals of the individual resistance. In our next video, we will try to solve various problems related to resistors and their connection.